Hello and welcome back to Cotton Innovations Limited. In this series we're going to be looking at design of experiments. What are design of experiments? How do we set design of experiments up? And just give you a little feel. Everybody talks about design of experiment. What is it? What is it we want to do? Well, typically a design of experiment is looking at the relationship of various factors to see what they do. We've drawn a cube here because we're going to look at three factors, and an everyday example that we'd find is something like one of these blister packs. The blister pack's got 4 pens in it. The blister pack has a backing card. It has a piece of plastic which is vacuum formed, which holds the container, and then they're glued together. And if you ever wondered how these are glued together, that's what we're going to spend some time looking at today. How do we create that? We're also going to look at some of the models that we need to put in place about how do we set up a design of experiment. What is the factors we need to understand? How do we control our experiment? And what are the things we need to do to make sure that we get a great experiment? Because it's so easy to do these and also to mess them up. So when we look at welding something like this together, what we actually need is 3 key elements. The first element is heat. So what they would do is they would put the piece of plastic into a machine. The machine would, they would have already preloaded into that machine the various pens, and then they'd place the backing card on the top of this piece of plastic. There would then be a hot iron that would come down and would press on here. This part of the frame here would be supported, and just like ironing a shirt or just like ironing some clothes, they would literally place a hot iron on there, and the heat transfer would activate the glue on this surface and cause these two to weld together. So that's the first thing we need, is heat. The second thing we need is time. Time is really important. For example, if we were to put a candle, and you put your fingers through a candle, if you do it very quickly, you don't feel the heat. If you do it very slowly, and you're foolish enough to do it slowly, you'll burn your skin. So the energy that's released by the heat is a function of time. So we can have a long time, we can have a short time. One of the things we need to understand is with some materials, they're very, very sensitive to time and heat. So if you increase the time too much, increase the heat too much, this plastic form will wrinkle. If you don't heat it enough, the glue won't activate and the two won't stick together. So you'll either end up with a wrinkle or you'll end up with a gapping on the side. And you may have seen those when you're in the shops. You notice that products is starting to pop out, and that's because either the time or the heat on the machine was not quite set right. Then there's a third factor, and that factor is called pressure. And that's the amount of force that you apply on here. Now, force is really important because it enables the heat to transfer through very quickly. If we have a light force, we can have lots of heat, low pressure, long period of time, but the two surfaces aren't being pushed together. You don't get a good weld. Equally, you can push it too hard, and with the heat and the time, and you'll cause the materials to burn or to wrinkle. So we need to understand how these interact. That's what we're trying to do with the design of experiment, is understand how these factors interact. Now, the reason we've drawn a cube is because we'll call heat A, we'll call time B, and we'll call pressure C. So A will be this factor here. So we can have a low to a high temperature setting for A. Equally for B, we can have B going in this direction, and it will go low to high. So put an arrow in here to show which way it's going to go. And then also the third factor is C, which is pressure. So C would be here, and we can have it going in low here and high here. Now, because of the way design of experiments works, we have 3 factors, we have 2 levels of experiment. That gives us 8 corners on the cube, and it works to the power. So 2 raised to the power of 3 gives us 8. So 3 factors gives us 8 experiments. 8 experiments means that we can look at A, we can look at B, and we can look at C. 3 factors, how do they interact? In other words, we can look at this surface, we can look at this surface, we can look at this surface. We could also look at the interaction of A and B, which means how does this area here, so how does A work with B in terms of that plane? We can look at A versus C, so we can look at this surface and this surface to see how that interacts. And then we can look at B versus C. So there would be these would call our two-way interactions. But then we could get a third interaction, which we call A, B, and C all together. That would be our third-way interaction. So what we're doing here when we're looking at AB, AC, BC, this side, this side, this side, that side, this side, and the back side of the cube. When we're looking at A, B, and C, we're looking at this surface, or this surface, or this surface. And when we're looking at A, B, C, we're looking at inside the cube. So what the experiment can do is it can give us an understanding of how to understand which factors are the most significant, how to find an optimum point, how to set that. In the following videos, we're going to talk about the things you need to do to set up your design of experiment, things you need to be aware of. But if you're doing a DoE, reach out to us at Cotton Innovations Limited. We'd love to help. We'd love to show you. We'd love to help you design your experiment and help you talk your way through it as you do all of your stuff. There's a lot more you need to understand. But if you want to come on one of our courses for design of experiment, we'd love to talk to you. Love to interact with you and help you understand what we need to do. So again, all the details are on the screen. Please reach out to us, and we look forward to contacting you and you contacting us, and we can talk about your design of experiment. Thank you very much.